Section 7 of My Inventions and Other Works of Nikola Tesla, Electrical Experimenter, February to October 1919. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Famous Scientific Illusions by Nikola Tesla. This article was published in Electrical Experimenter, February 1919. In this original and revolutionizing discussion, Nikola Tesla gives us something really new to think about. First, does the moon rotate on its axis? Second, is the Franklin pointed lightning rod correct in theory and operation? Third, do wireless signals fly through space by means of so-called Hertzian waves in the ether, or are they propagated through the earth at prodigious velocity by means of earth-bound oscillations? World-famous conundrums these, questions which have been answered in many ways by some of the greatest scientists. Dr. Tesla explains these three predominant scientific fallacies in a masterly way so that everyone can understand them. The human brain, with all its wonderful capabilities and power, is far from being a faultless apparatus. Most of its parts may be in perfect working order, but some are atrophied, undeveloped, or missing altogether. Great men of all classes and professions, scientists, inventors, and hard-headed financiers, have placed themselves on record with impossible theories, inoperable devices, and unreliable schemes. It is doubtful that there could be found a single work of any one individual free of error. There is no such thing as an infallible brain. Invariably, some cells or fibers are wanting or unresponsive, with the result of impairing judgment, sense of proportion, or some other faculty. A man of genius eminently practical, whose name is a household word, has wasted the best years of his life in a visionary undertaking. A celebrated physicist was incapable of tracing the directions of an electric current according to a childishly simple rule. The writer, who was known to recite entire volumes by heart, has never been able to retain in memory and recapitulate in their proper order the words designating the colors of the rainbow, and can only ascertain them after long and laborious thought, strange as it may seem. Our organs of reception, too, are deficient and deceptive. As a semblance of life is produced by a rapid succession of inanimate pictures, so many of our perceptions are but trickery of the senses, devoid of reality. The greatest triumphs of man were those in which his mind had to free itself from the influence of delusive appearances. Such was the revelation of Buddha that self is an illusion caused by the persistence and continuity of mental images; the discovery of Copernicus that, contrary to all observation, this planet rotates around the sun; the recognition of Descartes that the human being is an automaton, governed by external influence, and the idea that the earth is spherical, which led Columbus to the finding of this continent. And though the minds of individuals supplement one another, and science and experience are continually eliminating fallacies and misconceptions, much of our present knowledge is still incomplete and unreliable. We have sophisms in mathematics which cannot be disproved. Even in pure reasoning, free of the shortcomings of symbolic processes, we are often arrested by doubt which the strongest intelligences have been unable to dispel. Experimental science itself, most positive of all, is not unfailing. In the following I shall consider three exceptionally interesting errors in the interpretation and application of physical phenomena, which have for years dominated the minds of experts and men of science. 1. The illusion of the axial rotation of the moon. It is well known since the discovery of Galileo that the moon, in traveling through space, always turns the same face towards the earth. This is explained by saying that while passing once around the mother planet, the lunar globe performs just one revolution on its axis. the spinning motion of a heavenly body must necessarily undergo modifications in the course of time, being either retarded by resistances internal or external, or accelerated owing to shrinkage and other causes. An unalterable rotational velocity through all phases of planetary evolution is manifestly impossible. What wonder, then, that at this very instant of its long existence our satellite should revolve exactly so, and not faster or slower. But many astronomers have accepted as physical fact that such rotation takes place. It does not, but only appears so. It is an illusion, a most surprising one, too. I will endeavor to make this clear by reference to Figure 1, in which E represents the Earth and M the Moon. The movement through space is such that the arrow, firmly attached to the latter, always occupies the position indicated with reference to the Earth. If one imagines himself as looking down on the orbital plane and follows the motion, he will become convinced that the moon does turn on its axis as it travels around. But in this very act the observer will have deceived himself. To make the delusion complete, let him take a washer similarly marked, and supporting it rotatably in the center, carry it around a stationary object, constantly keeping the arrow pointing towards the latter. Though to his bodily vision the disc will revolve on its axis, such movement does not exist. He can dispel the illusion at once by holding the washer fixedly while going around. He will now readily see that the supposed axial rotation is only apparent, an impression being produced by successive changes of position in space. But more convincing proofs can be given that the moon does not and cannot revolve on its axis. With this object in view, attention is called to Figure 2, in which both the satellite M and the earth E are shown embedded in a solid mass, M1, indicated by stippling, and supposed to rotate so as to impart to the moon its normal translatory velocity. Evidently, if the lunar globe could rotate as commonly believed, this would be equally true of any other portion of mass M1, as the sphere M2, shown in dotted lines, and then the part common to both bodies would have to turn simultaneously in opposite directions. This can be experimentally illustrated in the manner suggested, by using instead of one, two overlapping rotatable washers, as may be conveniently represented by circles M and M2, and carrying them around a center as E, so that the plane and dotted arrows are always pointing towards the same center. No further argument is needed to demonstrate that the two gyrations cannot coexist, or even be pictured in the imagination and reconciled in a purely abstract sense. The truth is, the so-called axial rotation of the moon is a phenomenon deceptive alike to the eye and mind, and devoid of physical meaning. It has nothing in common with real mass revolution characterized by effects positive and unmistakable. Volumes have been written on the subject, and many erroneous arguments advanced in support of the notion. Thus it is reasoned that if the planet did not turn on its axis, it would expose the whole surface to terrestrial view. As only one half is visible, it must revolve. The first statement is true, but the logic of the second is defective, for it admits of only one alternative. The conclusion is not justified, as the same appearance can also be produced in another way. The moon does rotate, not on its own, but about an axis passing through the center of the earth, the true and only one. The unfailing test of the spinning of a mass is, however, the existence of energy of motion. The moon is not possessed of such vis viva. If it were the case, then a revolving body, as M1, would contain mechanical energy other than that of which we have experimental evidence. Irrespective of this, so exact a coincidence between the axial and orbital periods is in itself immensely improbable, for this is not the permanent condition towards which the system is tending. Any axial rotation of a mass left to itself, retarded by forces external or internal, must cease. Even admitting its perfect control by tides, the coincidence would still be miraculous. But when we remember that most of the satellites exhibit this peculiarity, the probability becomes infinitesimal. 3 theories have been advanced for the origin of the moon. According to the oldest suggested by the great German philosopher Kant, and developed by Laplace in his monumental treatise Mécanique Céleste, the planets have been thrown off from larger central masses by centrifugal force. Nearly 40 years ago Professor George H. Darwin, in a masterful essay on tidal friction, furnished mathematical proofs, deemed unrefutable, that the moon had separated from the earth. Recently this established theory has been attacked by Professor T.J.J. See in a remarkable work on the "Evolution of the Stellar Systems," in which he propounds the view that centrifugal force was altogether inadequate to bring about the separation, and that all planets, including the moon, have come from the depths of space, and have been captured. Still a third hypothesis, of unknown origin, exists, which has been examined and commented upon by Professor W. H. Pickering in Popular Astronomy of 1907, and according to which the moon was torn from the earth when the latter was partially solidified, this accounting for the continents, which might not have been formed otherwise. Undoubtedly planets and satellites have originated in both ways, and, in my opinion, it is not difficult to ascertain the character of their birth. The following conclusions can be safely drawn. 1. A heavenly body thrown off from a larger one cannot rotate on its axis. The mass, rendered fluid by the combined action of heat and pressure, upon the reduction of the latter, immediately stiffens, being at the same time deformed by gravitational pull. The shape becomes permanent upon cooling and solidification, and the smaller mass continues to move about the larger one, as though it were rigidly connected to it, except for pendular swings or librations due to varying orbital velocity. Such motion precludes the possibility of axial rotation in the strictly physical sense. The moon has never spun around, as is well demonstrated by the fact that the most precise instruments have failed to show any measurable flattening in form. 2. If a planetary body in its orbital movement turns the same side towards the central mass, this is a positive proof that it has been separated from the latter, and is a true satellite. 3. A planet revolving on its axis in its passage around another cannot have been thrown off from the same, but must have been captured. 2. The fallacy of Franklin's pointed lightning rod. The display of atmospheric electricity has since ages been one of the most marvelous spectacles afforded to the sight of man. Its grandeur and power filled him with fear and superstition. For centuries he attributed lightning to agents godlike and supernatural, and its purpose in the scheme of this universe remained unknown to him. Now we have learned that the waters of the ocean are raised by the sun and maintained in the atmosphere delicately suspended, that they are wafted to distant regions of the globe where electric forces assert themselves in upsetting the sensitive balance and causing precipitation, thus sustaining all organic life. There is every reason to hope that man will soon be able to control this life-giving flow of water and thereby solve many pressing problems of his existence. Atmospheric electricity became of special scientific interest in Franklin's time. Faraday had not yet announced his epochal discoveries in magnetic induction, but static frictional machines were already generally used in physical laboratories. Franklin's powerful mind at once leaped to the conclusion that frictional and atmospheric electricity were identical. To our present view this inference seems obvious, but in his time the mere thought of it was little short of blasphemy. He investigated the phenomena, and argued that if they were of the same nature, then the clouds would be drained of all their charge exactly as the ball of a static machine; and in 1749 he indicated in a published memoir how this could be done by the use of pointed metal rods. The earliest trials were made by Dallebrand in France, but Franklin himself was the first to obtain a spark by using a kite, in June, 1752. When these atmospheric discharges manifest themselves today in our wireless station, we feel annoyed, and wish that they would stop, but to the man who discovered them they brought tears of joy. The lightning conductor in its classical form was invented by Benjamin Franklin in 1755, and immediately upon its adoption proved a success to a degree. As usual, however, its virtues were often exaggerated. So, for instance, it was seriously claimed that in the city of Pietermaritzburg, capital of Natal, South Africa, no lightning strikes occurred after the pointed rods were installed, although the storms were as frequent as before. Experience has shown that just the opposite is true. A modern city like New York, presenting innumerable sharp points and projections in good contact with the earth, is struck much more often than equivalent area of land. Statistical records, carefully compiled and published from time to time, demonstrate that the danger from lightning to property and life has been reduced to a small percentage by Franklin's invention, but the damage by fire amounts nevertheless to several $1,000,000 annually. It is astonishing that this device, which has been in universal use for more than 1 century and a half, should be found to involve a gross fallacy in design and construction, which impairs its usefulness, and may even render its employment hazardous under certain conditions. For explanation of this curious fact, I may first refer to Fig. 3, in which S is a metallic sphere of radius r, such as the capacity terminal of a static machine, provided with a sharply pointed pin of length h as indicated. It is well known that the latter has the property of quickly dissipating the accumulated charge into the air. To examine this action in the light of present knowledge, we may liken electric potential to temperature. Imagine that sphere S is heated to T degrees, and that the pin or metal bar is a perfect conductor of heat, so that its extreme end is at the same temperature T. Then, if another sphere of larger radius, V1, is drawn about the first, and the temperature along this boundary is T1, it is evident that there will be between the end of the bar and its surrounding a difference of temperature, T minus T1, which will determine the outflow of heat. Obviously, if the adjacent medium was not affected by the hot sphere, this temperature difference would be greater and more heat would be given off. Exactly so in the electric system. Let Q be the quantity of the charge, then the sphere, and owing to its great conductivity also the pin, will be at the potential Q divided by R. The medium around the point of the pin will be at the potential Q divided by R1 equals Q divided by the sum R plus H, and consequently the difference Q divided by R minus Q divided by the sum R plus H equals QH divided by the quantity R times the sum of R plus H. Suppose now that a sphere S of much larger radius, capital R equals lowercase nr, is employed containing a charge uppercase Q. This difference of potential will be, analogously, capital QH divided by the product capital R times the sum capital R plus H. According to elementary principles of electrostatics, the potentials of the two spheres, lowercase s and uppercase s, will be equal if uppercase Q equals lowercase nq, in which case capital QH divided by the product capital R times the sum capital R plus H equals the product lowercase nqh divided by the product lowercase nr times the sum NR plus H, equals lowercase qh divided by the product lowercase r times the sum NR plus H. Thus the difference of potential between the point of the pin and the medium around the same will be smaller in the ratio R plus H divided by NR plus H when the large sphere is used. In many scientific tests and experiments, this important observation has been disregarded with the result of causing serious errors. Its significance is that the behavior of the pointed rod entirely depends on the linear dimensions of the electrified body. Its quality to give off the charge may be entirely lost if the latter is very large. For this reason, all points or projections on the surface of a conductor of such vast dimensions as the earth would be quite ineffective were it not for other influences. These will be elucidated with reference to Figure 4, in which our artist of the Impressionist school has emphasized Franklin's notion that his rod was drawing electricity from the clouds. If the earth were not surrounded by an atmosphere which is generally oppositely charged, it would behave, despite all its irregularities of surface, like a polished sphere. But owing to the electrified masses of air and cloud, the distribution is greatly modified. Thus in Figure 4, the positive charge of the cloud induces in the earth an equivalent opposite charge, the density at the surface of the latter diminishing with the cube of the distance from the static center of the cloud. A brush discharge is then formed at the point of the rod, and the action Franklin anticipated takes place. In addition, the surrounding air is ionized and rendered conducting, and eventually a bolt may hit the building or some other object in the vicinity. The virtue of the pointed end to dissipate the charge, which was uppermost in Franklin's mind, is, however, infinitesimal. Careful measurements show that it would take many years before the electricity stored in a single cloud of moderate size would be drawn off or neutralized through such a lightning conductor. The grounded rod has the quality of rendering harmless most of the strokes it receives, though occasionally the charge is diverted with damaging results. But, what is very important to note, it invites danger and hazard on account of the fallacy involved in its design. The sharp point, which was thought advantageous and indispensable to its operation, is really a defect, detracting considerably from the practical value of the device. I have produced a much improved form of lightning protector, characterized by the employment of a terminal of considerable area and large radius of curvature, which makes impossible undue density of the charge and ionization of the air. Footnote: Refer to the October 1918 issue of this journal, wherein Dr. Tesla's new form of non-pointed lightning rod was fully described and illustrated. End footnote. These protectors act as quasi-repellents, and so far have never been struck, though exposed a long time. Their safety is experimentally demonstrated to greatly exceed that invented by Franklin. By their use, property worth millions of dollars which is now annually lost can be saved. 3. The singular misconception of the wireless. To the popular mind this sensational advance conveys the impression of a single invention, but in reality it is an art, the successful practice of which involves the employment of a great many discoveries and improvements. I viewed it as such when I undertook to solve wireless problems, and it is due to this fact that my insight into its underlying principles was clear from their very inception. In the course of development of my induction motors, it became desirable to operate them at high speeds, and for this purpose I constructed alternators of relatively high frequencies. The striking behavior of the currents soon captivated my attention, and in 1889 I started a systematic investigation of their properties and the possibilities of practical application. The first gratifying result of my efforts in this direction was the transmission of electrical energy through one wire without return, of which I gave demonstrations in my lectures and addresses before several scientific bodies here and abroad in 1891 and 1892. During that period, while working with my oscillation transformers and dynamos of frequencies up to 200,000 cycles per second, the idea gradually took hold of me that the earth might be used in place of the wire, thus dispensing with artificial conductors altogether. The immensity of the globe seemed an unsurmountable obstacle, but after a prolonged study of the subject, I became satisfied that the undertaking was rational, and in my lectures before the Franklin Institute and National Electric Light Association early in 1893, I gave the outline of the system I had conceived. In the latter part of that year, at the Chicago World's Fair, I had the good fortune of meeting Professor Helmholtz, to whom I explained my plan, illustrating it with experiments. On that occasion I asked the celebrated physicist for an expression of opinion on the feasibility of the scheme. He stated unhesitatingly that it was practicable, provided I could perfect apparatus capable of putting it into effect, but this, he anticipated, would be extremely difficult to accomplish. I resumed the work very much encouraged, and from that date to 1896 advanced slowly but steadily, making a number of improvements, the chief of which was my system of concatenated tuned circuits, and method of regulation, now universally adopted. In the summer of 1897 Lord Kelvin happened to pass through New York, and honored me by a visit to my laboratory, where I entertained him with demonstrations in support of my wireless theory. He was fairly carried away with what he saw, but, nevertheless, condemned my project in emphatic terms, qualifying it as something impossible, an illusion and a snare. I had expected his approval, and was pained and surprised; but the next day he returned, and gave me a better opportunity for explanation of the advances I had made, and of the true principles underlying the system I had evolved. Suddenly he remarked with evident astonishment, "Then you are not making use of Hertz waves?" "Certainly not," I replied. "These are radiations. No energy could be economically transmitted to a distance by any such agency. In my system the process is one of true conduction, which, theoretically, can be effected at the greatest distance without appreciable loss." I can never forget the magic change that came over the illustrious philosopher the moment he freed himself from that erroneous impression. The skeptic, who would not believe, was suddenly transformed into the warmest of supporters. He parted from me not only thoroughly convinced of the scientific soundness of the idea, but strongly expressed his confidence in its success. In my exposition to him I resorted to the following mechanical analogues of my own and the Hertz wave system. Imagine the earth to be a bag of rubber filled with water, a small quantity of which is periodically forced in and out of the same by means of a reciprocating pump, as illustrated. If the strokes of the latter are effected in intervals of more than 1 hour and 48 minutes, sufficient for the transmission of the impulse through the whole mass, the entire bag will expand and contract, and corresponding movements will be imparted to pressure gauges or movable pistons with the same intensity, irrespective of distance. By working the pump faster, shorter waves will be produced, which, on reaching the opposite end of the bag, may be reflected and give rise to stationary nodes and loops. But in any case, the fluid being incompressible, its enclosure perfectly elastic, and the frequency of oscillations not very high, the energy will be economically transmitted, and very little power consumed, so long as no work is done in the receivers. This is a crude but correct representation of my wireless system, in which, however, I resort to various refinements. Thus, for instance, the pump is made part of a resonant system of great inertia, enormously magnifying the force of the impressed pulses. The receiving devices are similarly conditioned, and in this manner the amount of energy collected in them vastly increased. The Hertz wave system is in many respects the very opposite of this. To explain it by analogy, the piston of the pump is assumed to vibrate to and fro at a terrific rate, and the orifice through which the fluid passes in and out of the cylinder is reduced to a small hole. There is scarcely any movement of the fluid, and almost the whole work performed results in the production of radiant heat, of which an infinitesimal part is recovered in a remote locality. However incredible, it is true that the minds of some of the ablest experts have been from the beginning, and still are, obsessed by this monstrous idea, and so it comes that the true wireless art, to which I laid the foundation in 1893, has been retarded in its development for 20 years. This is the reason why the statics have proved unconquerable, why the wireless shares are of little value, and why the government has been compelled to interfere. We are living on a planet of well nigh inconceivable dimensions, surrounded by a layer of insulating air, above which is a rarefied and conducting atmosphere (Fig. 5). This is providential, for if all the air were conducting, the transmission of electrical energy through the natural media would be impossible. My early experiments have shown that currents of high frequency and great tension readily pass through an atmosphere but moderately rarefied, so that the insulating stratum is reduced to a small thickness, as will be evident by inspection of Fig. 6, in which a part of the earth and its gaseous envelope is shown to scale. If the radius of the sphere is 12½ inches, then the non-conducting layer is only 1/64 of an inch thick, and it will be obvious that the Hertzian rays cannot traverse so thin a crack between two conducting surfaces for any considerable distance without being absorbed. The theory has been seriously advanced that these radiations pass around the globe by successive reflections, but to show the absurdity of this suggestion reference is made to Fig. 7, in which this process is diagrammatically indicated. Assuming that there is no refraction, the rays, as shown on the right, would travel along the sides of a polygon drawn around the solid, and inscribed into the conducting gaseous boundary, in which case the length of the side would be about 400 miles. As 1/2 the circumference of the earth is approximately 12,000 miles long, there will be, roughly, 30 deviations. The efficiency of such a reflector cannot be more than 25%, so that if none of the energy of the transmitter were lost in other ways, the part recovered would be measured by the fraction 1/4 to the 30th power. Let the transmitter radiate Hertz waves at the rate of 1,000 kilowatts. Then 115 billionth part of 1 watt is all that would be collected in a perfect receiver. In truth, the reflections would be much more numerous, as shown on the left of the figure, and owing to this and other reasons, on which it is unnecessary to dwell, the amount recovered would be a vanishing quantity. Consider now the process taking place in the transmission by the instrumentalities and methods of my invention. For this purpose attention is called to Fig. 8, which gives an idea of the mode of propagation of the current waves, and is largely self-explanatory. The drawing represents a solar eclipse, with the shadow of the moon just touching the surface of the earth at a point where the transmitter is located. As the shadow moves downward, it will spread over the earth's surface, first with infinite and then gradually diminishing velocity, until at a distance of about 6,000 miles it will attain its true speed in space. From there on it will proceed with increasing velocity, reaching infinite value at the opposite point of the globe. It hardly need be stated that this is merely an illustration, and not an accurate representation in the astronomical sense. The exact law will be readily understood by reference to Fig. 9, in which a transmitting circuit is shown connected to earth and to an antenna. The transmitter being in action, two effects are produced. Hertz waves pass through the air, and a current traverses the earth. The former propagate with the speed of light, and their energy is unrecoverable in the circuit. The latter proceeds with the speed varying as the cosecant of the angle which a radius drawn from any point under consideration forms with the axis of symmetry of the waves. At the origin the speed is infinite, but gradually diminishes until a quadrant is traversed; then the velocity is that of light. From there on it again increases, becoming infinite at the antipole. Theoretically, the energy of this current is recoverable in its entirety, in properly attuned receivers. Some experts, whom I have credited with better knowledge, have for years contended that my proposals to transmit power without wires are sheer nonsense, but I note that they are growing more cautious every day. The latest objection to my system is found in the cheapness of gasoline. These men labor under the impression that the energy flows in all directions, and that, therefore, only a minute amount can be recovered in any individual receiver. But this is by far from being so. The power is conveyed in only one direction, from the transmitter to the receiver, and none of it is lost elsewhere. It is perfectly practicable to recover at any point of the globe energy enough for driving an airplane, or a pleasure boat, or for lighting a dwelling. I am especially sanguine in regard to the lighting of isolated places, and believe that a more economical and convenient method can hardly be devised. The future will show whether my foresight is as accurate now as it has proved heretofore. End of Section 7.
Section 8 of My Inventions and Other Works of Nikola Tesla, Electrical Experimenter, February to October 1919. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information, or to volunteer, please visit LibriVox.org. Recording by Devorah Allen. Tesla's Egg of Columbus by Nikola Tesla. This article was published in Electrical Experimenter, March 1919. Tesla's Egg of Columbus. How Tesla performed the feat of Columbus without cracking the egg. Probably one of the most far-reaching and revolutionary discoveries made by Mr. Tesla is the so-called rotating magnetic field. This is a new and wonderful manifestation of force, a magnetic cyclone, producing striking phenomena which amazed the world when they were first shown by him. It results from the joint action of two or more alternating currents definitely related to one another, and creating magnetic fluxes, which, by their periodic rise and fall according to a mathematical law, cause a continuous shifting of the lines of force. There is a vast difference between an ordinary electromagnet and that invented by Tesla. In the former, the lines are stationary. In the latter, they are made to whirl around at a furious rate. The first attracts a piece of iron and holds it fast. The second causes it to spin in any direction and with any speed desired. Long ago, when Tesla was still a student, he conceived the idea of the rotating magnetic field, and this remarkable principle is embodied in his famous induction motor and system of transmission of power now in universal use. In this issue of the Electrical Experimenter, Mr. Tesla gives a remarkable account of his early efforts and trials as an inventor, and of his final success. Unlike other technical advances, arrived at through the usual hit-and-miss methods and haphazard experimentation, the rotating field was purely the work of scientific imagination. Tesla developed and perfected, entirely in his mind, this great idea in all its details and applications, without making one single experiment. Not even the usual first model was used. When the various forms of apparatus he had devised were tried for the first time, they worked exactly as he had imagined, and he took out some 40 fundamental patents covering the whole vast region he had explored. He obtained the first rotations in the summer of 1883, after 5 years of constant and intense thought on the subject, and then undertook the equally difficult task of finding believers in his discovery. The alternating current was but imperfectly understood, and had no standing with engineers or electricians, and for a long time Tesla talked to deaf ears. But ultimately his pains were rewarded, and early in 1887 a company bearing his name was formed for the commercial introduction of the invention. Dr. Tesla recently told the editors an amusing incident in this connection. He had approached a Wall Street capitalist, a prominent lawyer, with a view of getting financial support, and this gentleman called in a friend of his, a well-known engineer at the head of one of the big corporations in New York, to pass upon the merits of the scheme. This man was a practical expert, who knew of the failures in the industrial exploitation of alternating currents, and was distinctly prejudiced to a point of not caring even to witness some tests. After several discouraging conferences, Mr. Tesla had an inspiration. Everybody has heard of the egg of Columbus. The saying goes that at a certain dinner the great explorer asked some scoffers of his project to balance an egg on its end. They tried it in vain. He then took it, and cracking the shell slightly by a gentle blow, made it stand upright. This may be a myth, but the fact is that he was granted an audience by Isabella, the Queen of Spain, and won her support. There is a suspicion that she was more impressed by his portly bearing than the prospect of his discovery. Whatever it might have been, the Queen pawned her jewels, and 3 ships were equipped for him, and so it happened that the Germans got all that was coming to them in this war. But to return to Tesla's reminiscence. He said to these men, "Do you know the story of the egg of Columbus?" Of course they did. "Well," he continued, "what if I could make an egg stand on the pointed end without cracking the shell?" If you could do this, we would admit that you had gone Columbus one better. And would you be willing to go out of your way as much as Isabella? We have no crown jewels to pawn, said the lawyer, who was a wit. But there are a few ducats in our buckskins, and we might help you to an extent. Mr. Tesla thus succeeded in capturing the attention and personal interest of these very busy men, extremely conservative and reluctant to go into any new enterprise, and the rest was easy. He arranged for a demonstration the following day. A rotating field magnet was fastened under the top board of a wooden table, and Mr. Tesla provided a copper-plated egg and several brass balls and pivoted iron discs for convincing his prospective associates. He placed the egg on the table, and to their astonishment it stood on end. But when they found that it was rapidly spinning, their stupefaction was complete. The brass balls and pivoted iron discs in turn were set spinning rapidly by the rotating field, to the amazement of the spectators. No sooner had they regained their composure than Tesla was delighted with the question, "Do you want any money?" "Columbus was never in a worse predicament," said the great inventor, who had parted with his last portrait of George Washington in defraying the expenses of the preparation. Before the meeting adjourned, he had a substantial check in his pocket, and it was given with the assurance that there was more to be had in the same bank. That started the ball rolling. Tens of millions of horsepower of Tesla's induction motors are now in use all over the world, and their production is rising like a flood. In 1893, Mr. Albert Schmid, then superintendent of the Westinghouse Electric and Manufacturing Company, constructed a powerful rotating field ring with an egg made of copper, and larger than that of an ostrich, for Dr. Tesla's personal collection at the Chicago World's Fair. This piece of apparatus was one of the most attractive novelties ever publicly shown, and drew enormous crowds every day. Subsequently it was taken to Mr. Tesla's laboratory, and served there permanently for demonstrating rotating field phenomena. In his experiments it was practicable to use as much as 200 horsepower for a short time, without overheating the wires, and the effects of the magnetic forces were wonderfully fascinating to observe. This is the very ring indicated in the accompanying photograph, Figure 1, giving a view of Mr. Tesla's former laboratory at 46 East Houston Street, New York. It is shown in detail in Figure 2, and the mode of winding is illustrated in diagram Figure 3. Originally the 2-phase arrangement was provided, but Mr. Tesla transformed it to the 3- and 4-phase when desired. On top of the ring was fastened a thin circular board, slightly hollowed, and provided around its circumference with a guard to prevent the objects from flying off. Even more interesting than the spinning egg was the exhibition of planetary motion. In this experiment, one large and several small brass balls were usually employed. When the field was energized, all the balls would be set spinning, the large one remaining in the center, while the small ones revolved around it, like moons about a planet, gradually receding until they reached the outer guard, and raced along the same. But the demonstration which most impressed the audiences was the simultaneous operation of numerous balls, pivoted discs, and other devices placed in all sorts of positions, and at considerable distances from the rotating field. When the currents were turned on, and the whole animated with motion, it presented an unforgettable spectacle. Mr. Tesla had many vacuum bulbs in which small, light metal discs were pivotally arranged on jewels, and these would spin anywhere in the hall when the iron ring was energized. Rotating fields of 15,000 horsepower are now being turned out by the leading manufacturers, and it is very likely that in the near future capacities of 50,000 horsepower will be employed in the steel and other industries and ship propulsion by Tesla's electric drive, which, according to Secretary of the Navy Daniels's statement, has proved a great success. But any student interested in these phenomena can repeat all the classical experiments of Tesla by inexpensive apparatus. For this purpose, it is only necessary to make 2 slip-ring connections on an ordinary small direct current motor or dynamo, and to wind an iron ring with 4 coils, as indicated in diagram Fig. 3. No particular rule need be given for the windings, but it may be stated that he will get the best results if he will use an iron ring of comparatively small section, and wind it with as many turns of stout wire as practicable. He can heavily copper plate an egg, but he should bear in mind that Tesla's egg is not as innocent as that of Columbus. The worst that can happen with the latter is that it might be overripe, but the Tesla egg may explode with disastrous effect, because the copper plating is apt to be brought to a high temperature through the induced currents. The sensible experimenter will therefore first suck out the contents of the egg, thus satisfying both his appetite and thirst for knowledge. Besides the rotating field apparatus, Mr. Tesla had other surprises for his audiences, which were even more wonderful. So, for instance, the coil on 3 legs, visible in the foreground, was used to operate wireless motors, lamps, and other devices, and the spiral coil in the background served to show extraordinary high potential phenomena as streamers of great length. End of section 8.